Okay, I'm Masashi Usami of KDDI, from KDDI, which is Japan's telecom operator. So it is my great pleasure to be able to give a keynote talk about 5G. So you know that the 5G services have started here in the States and in many other countries from last year. But it's just beginning of the long evolving process to a full penetration of 5G. So today I'm going to talk on various efforts to activate 5G services in Japan. Okay, and I'm pleased if you might have enjoyed my talk and you get some hints for further development of consumer electronics and consumer technology, society, and industry. Okay, so here shows an outline of my talk. Maybe too many contents here. So let's start the introduction. As already mentioned, the 5G services have started in the world. So more than 50 operators in 27 countries launched already 5G last year. So in the US, the Verizon, AT&T, Sprint, T-Mobile, and Europe, and Middle East and Africa, and China and Australia. And in South Korea, more than 3 million people enjoy the 5G already. So in Japan, a little bit behind, but we are ready to go. 4 operators in Japan were allocated 5G bands of 3.7 and 4.5 gigahertz band, and of 28 gigahertz millimeter wave band. So KDDI was allocated global bands, so 2 bands of at 3.5G, a 5 gigahertz band, and one 400 megahertz band at 28 gigahertz band. And this shows 5G development plans for of each operator. As you see, the KDD has proposed the most aggressive plan like this. So we will launch 5G service in this March, very soon. And in 5 years, the over 90% of the nationwide area will be covered by 5G. So maybe some of you don't know what KDDI is. So I would like to briefly introduce KDDI. So KDDI is the second largest telecom operator in Japan. And we have a 28% share of mobile subscribers. But as you see in this chart, the competition of operators are very severe competition. And so this is the revenue distribution in KDDI. So about 80% of our revenue comes from the personal consumer business, and others from enterprise. So we have much interest of consumer electronics, consumer technology, which are related to the smartphones, AR, VR, and IoT gears. Okay. So another keyword I would like to explain at first is AU. AU is KDDI's brand name, and in Japanese, AU is pronounced AO. It means to meet in English. So AU is symbolized for to meet someone, to meet you, to meet something. Okay. So maybe you know that this is an evolution of mobile generations. 3G is the first internet in handset. So maybe you know that in Japan, many unique services were evolved in 3G, such as a built-in NFC wallet 10 years ago. And instead of ringing tone, ringing personal preferred song service, and so on. But unfortunately, the proprietary platform are gone, and 4G smartphone is coming on the global platform. So you know that that's a real mobile internet right now. And what's next in 5G? The 5G is the era when everything is always connected, not only to human, but also the everything's. So this is a 5G starting plan in KDDI. So 3G will be decreasing. And at the beginning of the 5G network area will be limited and spotted. So in order to maintain the seamless service between 4G and 5G, a so-called NSA, non-standalone, the network basis is still widely covered by 4G. So KDDI has extensively involved the 4G network quality, improve the quality. So we call that network the hybrid network of shining 4G and special 5G. Okay, so before the coming 5G era, the KDDI has become Japan's first unlimited data plan provider. So everyone can access massive volume of data instantly, freely, and confidently just right now. Okay. And also we think that augment is the key word of 5G so as to create better experience. So the first two letters of augment is AU. So that is name as our brand name. Okay. So the introduction is over. So from now on, I would like to show several examples and many demonstration videos of new real experience provided in 5G. For example, Augmented Sports, Augmented Walk in town, and Augmented Entertainment by 5G. So first, Augmented Sports. So not only watching sports, but also playing sports are augmented by 5G. The first one is free viewpoint technology. So you may want to see sports event from your preferred angle. So far, you can select the preferred angle from multiple camera viewpoints, but we need many cameras like this. And the free viewpoint video technology enable us more. The 3D model-based rendering creates arbitrary viewpoints. For example, you can see the soccer game from a goalkeeper's view or a player's view, like this. So that is so-called walkthrough into player's field. So one exciting application of free viewpoint technology is the virtual reality. This is the comparison of free viewpoint and the conventional multi-viewpoint VR. The free viewpoint covers much wider range of selector viewpoint and needs less cameras. Rendering process time may be an issue sometimes, but we have recently succeeded to demonstrate a real-time operation. Okay, the first 5G trial was demonstrated on the Japan's professional baseball, the real match the last year. We set the 16 4K cameras around the Okinawa baseball field stand, and free viewpoint VR contents were produced from these 16 4K images in real time. So those contents were distributed by way of 5G to almost 50 users at the same time. The free viewpoint is produced like this. So this view produced by 16 4K images. So the second demonstration is the variable. In this case, we set 4 4K cameras, only 4 4K cameras around the court. So we can enjoy not only free-angled viewpoint, but also the player's view. So today, unfortunately, you do not have the VR goggles, so you can only experience the walkthrough on the screen. So let's take a look at the demonstration. At first, the professional baseball game in Okinawa field in June 2018. Okay, just the introduction. So real-time free viewpoint video stream using 5G. So viewpoint moving very smoothly, like this. Of course, the instant replay is also available, so we can watch just before the scene. Okay, this is the 4K camera. So we set the 16 cameras around the stands. And those images go to a server room to produce a free viewpoint contents. Okay, distribution by way of 5G. So we have 4 5G antennas on the pole. And the 28 gigahertz band we used. So we distributed to the 50 individual tablets at that case. Okay. So it's a real. So next one is a soccer goal scene. No sounds. So viewpoint moving very smoothly because that number of the camera is more than 10. So we can watch the game from the goalkeeper's view and the player's eye, and even from the upper bird's eye. Okay. So next one is the volleyball. Start. So women's volleyball game first. So we can watch the game from free angle around the court. Okay, the 3 times the same. Okay, so now next we can enter into the court. We can feel the player's experience like this. Okay. So next one is the men's game. So in this case, the free viewpoint was produced by only 4 cameras. So the rendering resolution is a little bit rough, but we can make the almost real-time contents. So this time you can be a blocking player near the net. Okay. Okay. So 5G is required to distribute such contents in each person, in each different contents distribution. So next topic is that 5G assists the university sports. The KDDI has contracted partnership with Japan's Association for University Sports for contributing to promote sports Japan. So this is Japanese kendos and soccer. So right now, the attractive example is pitching data measured by the sensor that is built in a ball like this. So we already, 20,000 pitchers have already accumulated the data, over 1 million pitching data in total so far. So, next. Okay, so the ball knows all, the censored ball knows all. And the sensor is built in the core of the board with a 9-axis sensor. The 3D acceleration, the 3D geomagnetic, and 3D angular velocity sensors. So the baseball itself is manufactured at the same weight. So the pitcher feels no difference in a standard ball. So data is the ball speed, revolution, rotation axis, ball type, displacement, and intensity of arm swing, everything. So it is very easy to measure just starting the smartphone application and video recording, and that's it. So all the data analyzed on the server in the real time. So another 5G demonstration on sports is World Cup of slackline full combination. So what is slackline? The slackline is like tightrope walking, but new sports with a new sense to perform performance freely on a 5-centimeter wide belt line. So high jump and backflip and turning, etc. And difficulty of performance is evaluated and scored. So such sports, so 5G supplies new experience of watching games. So at first, 5G can convey attractiveness of new sports like slackline by 4K video and visualization, many visualization. And also, 5G can convey more feeling of unity with players. So I will explain that. So this is a setup for 5G demonstration of slackline. And the 4K camera was transferred to the main big screen by way of 5G. And the motion camera made high judgment and difficulty judgment, which were also displayed on the main screen on real time. And additionally, the vibration information of the slackline was transferred to the seats of the spectators directly. So, okay, so in that experiment, the low latency of 5G is very, very essential to have a feeling of unity with players. Okay, the line is the 5-centimeter wide, the jumping on the line. The 17 athletes attending that the competition from the 6 countries. So this is, okay, jumping. So this is a very wide screen, 4K screen. And this is a 4K camera to shoot. And this is motion sensor camera to measure the height of the jump. Okay. And all the data was transmitted via 5G in real time. So real time is very important in this case. This is the 5G antennas. Okay, to the 4K monitor. So 4K image, and height level, trick level. So all together is on the display at the same time. And special option is the sensor was set to measure the vibration of the slack line. So the vibration was transferred to the viewer's seats in the real time. It's a 4DX movie theater, but this is a real experience. So low latency transmission of 5G enable us to have a very feeling of unity with players. Okay, I will skip this. So next move on the augmented walk. So you know the visual positioning service, visual positioning technology, VPS, is to realize the precise estimation of position and orientation from a query photo image. So by way of the best matching to the prepared 3D map database and query photo. So VPS on the smartphone can estimate the 3D buildings, structures, and also the surface exactly. Okay. I hope the movie is moving. Okay. So VPS in the smartphone, on the smartphone can estimate 3D buildings and structures and surface the real time. Okay. So by using this technology, we can collaborate AR with the real object. The city walking is augmented by the presenting real-time information on demand. So let's enjoy walking in Shibuya, the most crowded spot in Japan. I hope it works. Okay. Okay. She's waiting for her friends, and she has a little time to searching for a recommendation of today's walking spots. And I will skip this. Okay. So she's scanning the city of Shibuya around this. Yeah. So it's a swimming fish, or the AR, and he shoots the train station. So the real-time train information is displayed like this. And when she shoots the sky, the weather forecasts and temperature is displayed. So position of the reserved restaurant in the building is also shown. So it's augmented walking in the sky. Okay. So anyway, in this experiment, we use the 4G, but there are a lot of people in a crowded place. We need 5G broadband. So next topic is augmented entertainment, the new way of entertainment. So I hope the movie is working. The example is that Japan's first drone race was presented by way of 5G in Tokyo Motor Show in the last November. So this is the setup. They're almost the same, but in this case, 4K video of the race was shot from the shooting drone. The drone race is shot by shooting drone. And those contents were directly transferred to a big monitor on the stage by way of 5G. So real time is very important. So 5G is very fast, it's okay. But the 4K video codec processing time was sometime issue. So we have developed the 4K codec system. Its processing time is less than 100 milliseconds. So real-time operation was so important, feeling of unity in the race. Okay, so this is let's stop. Okay. So there are many players. The drone racer, the right upside, And racing drone, the right, the below, racing drone itself is very small, very fast. And the right hand side bottom is the 5G shooting drone. This is a large drone equipped with a 4K camera transmitted 5G. And the right up is the 5G antenna. Okay, sorry about that. Okay, the first, this is the drone venue, the real time. You see the very fast drone. This green, white is the drone. And next view from the shooting drone. So, okay, so sorry to explain. This view is shot by the shooting, 4K video. It's a slow motion right now. And next we can compare the real and live demo. So left side is the real time. And big screen is the live 4K video. So you see the almost the same, the real and the live video is the same. It's due to the low latency of 5G and the video codec. So these are the racing drones views. So this is the shooting. Okay, did you see the time difference between the live 4K video and real scene? So this is the owing to the 5G. So ICCE is an academic international conference. So let me introduce some research results of advanced technologies which supports basis of 5G in KDDI. So first is the optical access technologies. KDDI has a long around histories of optical transmission technology for fixed line networks so far, or the submarine cable systems. But recently, like this, the capacity of mobile network is approaching to that the optical access, fixed access network in the 5G era. So one challenge is how to accommodate such huge mobile traffic in fiber network efficiently. Okay. So mobile access line from the center office to the antenna, the last access line, is called front haul link. So right now, the radio waveform is digitized through the front haul link so far because of the digital signal is so stable. So due to this digitization process, much larger capacity than the original throughput is needed. For example, 150 megabps of radio wave throughput needs 2.5 gigabps. So that is 16 times larger. So in order to solve this, we transmitted radio signals over fiber as they are. That's the analog transmission, which leads to much higher spectral efficiency. But the analog transmission is so critical due to very low tolerance to noise. So by our special analog transmission technologies, we have recently succeeded in 1024 QAM transmission. That's the original radio waveform for mobile front haul link for the first time, so which is much larger capacity than the CPRI, the digital transmission does. So this technology is now proposed to the 5G standardization organization. And another technology is post-quantum cryptography. So a quantum computer may become real in the near future. So we need to develop a cryptographic algorithm secure against quantum computers. So we are studying many topics of the post-quantum cryptography from the fundamental theory to the applications like this. So in a crypt analysis, which is rather basic one, so we had achieved several world top records. In 2013, we got a world record on the ideal lattice challenge listed on this chart. And very recently, we are breaking the world record of syndrome decoding problem. So based on those technologies, now we are trying to study the fast algorithm for fully homomorphic encryption applications. So fully homomorphic encryption allows for the arbitrary computations on encrypted data. So we have recently achieved the fastest level algorithm of a fundamental function, so for fully homomorphic encryption. So this technology is utilized for the privacy preserving machine learning as a service. So that means the users do not leak any information about the data, such as personal photos and so on, for AI processing. So it may be very quite safe, even in the quantum computer age. So that's the one topic. Another topic is active recognition AI. So that knows who, where, how you're doing, what you're doing. So it deduced only the camera image. So it can exist 65 joints, skeletal movements in real time. So in this case, the fitness coaching example, so it can recognize the actual movements of split stance squat. So from the skeletal model, and give a proper advice to a trainee. It's a kind of commercial service. So, and more. So maybe 10 minutes ago, you see the baseball with the sensors. In this case, the sensors built inside the soccer ball. So combining sensor data and the skeletal models derived causal relationship of movement among actions more precisely. So let's take a look at an example. Okay. So a player is dribbling and kicks. So we can see the angle of instep is 16 degrees by the skeleton, and the hitting position is a little bit light side and ball, and the rotation is horizontal. Okay, so another example is almost the same. The same player is dribbling and kicks as before, but we can see the angle of instep is 0. Hitting position is, in this case, center. So the rotation is vertical. So almost the same form produced, but the complete different results. Maybe the player is very good player, so, but the analysis of this like this is very important for the players and for the viewers too. Okay, so next, in addition to new real experience for personal services, 5G is also strongly expected to solve the variety of social issues. So again, action recognition AI can be used for drone focused surveillance. Very far from the incident, we can see the abnormal behaviors such as struggling and falling down from a 4K vision from the drone. So in the scenario of the experiment, the guards and robots rush to the victims according to the instruction from the on-site center. So let's take a look. Okay. Okay, this is the stadium security experiment. And again, the 4K video shot from the drone is transmitted to the on-site center by way of 5G. So AI recognized the abnormal behavior. This is the on-site center. So this is the behavior recognition at the center. This is normal walking, but for example, this is an abnormal behavior. The struggling can be detected automatically by the AI. Okay, so 4K video can recognize human behavior even 50 meters away from the camera. So that is also owing to the ultra broadband feature of 5G. I will skip this. Okay. Again, that we can recognize the struggling and falling down very far from the incident. Okay, that's one example. So another one is that automated driving car. So in the auto driving car, 5G will support remote control of the car in the emergency accident of the car. And furthermore, the 5G will provide new services, interfaces, and applications in the future mobility style that is free from driving. So that's another issue. And last year, we have demonstrated a remote control experiment of automated car on public road by way of 5G. So in the US, that self-driving car is very common, but in Japan, this is the first experiment on the public road. So 4K signal, 4K and several video data were uploaded to the remote control center, and control commands were downlinked to the car. Okay, so in emergency, the low latency is very, very essential for such a critical mission of remote control of a car, fortunately. Okay, so the remote control of automated driving car on public road by 5G was demonstrated here. So I will skip this. So this is the car, and okay, 5G antenna on the roof. This is the 5G antenna. This central sensor is the radar. Okay. And the 4K video and other videos transferred to the center. And this. I will skip this. This is 4K camera on the. So regulation requires only the 30 kilometer per hour right now. Okay. So this is a remote control desk. The operator controls the car remotely in case of emergency. No delay of 5G is very, very essential. Okay. So another mission is remote control is that the construction machinery, so which is also required due to the decrease of machine operators. So this demonstration is two machines of a backhoe and a dump truck. Simultaneously remotely controlled by 5G. Okay. Again. this is the real construction field of a dam in Osaka area. Okay. So this is the 5G antenna of the machine, on the machine. This is backhoe. And the construction machines are 750 meters away from the remote control center. So this is a dump truck backhoe and the 5G base station here. The 5G antenna is on the roof. Okay, those are the same. So these three screens, machines are remotely controlled. The combination of two machines are well demonstrated. That is more realistic experiment. Okay, this is two. And traditional industry also, such as this Japanese sake brewery, also has a very high expectation on 5G. As you know, the fermentation process is very delicate and sensitive, as so in a wine brewery. Not only a limited master brewers can make it. 4K images of sake brewing chamber were remotely monitored via 5G. In this experiment, indoor transmission of millimeter wave was also well confirmed. And so the master brewers can see and control delicate fermentation status remotely, even from their home. So it is very helpful for sake production industry. Okay. You can. So this is the view of the sake brewing chamber from the top, 4K image. And this is the early stage of fermentation. So we can see a dynamic flow of fermentation like this. Okay. Okay. So you can see the dynamic flow here, the right-hand side. You see? Okay. This is easy to see. And next one, this is almost the final stage of fermentation. We can see a very tiny bubbles there, right-hand side. The tiny bubbles can be seen only by high-definition 4K images. Okay, can you see? These are the very tiny bubbles. So master brewers recognize that the status of the control, the process from this view, even he is in a home. So far, he is staying at the brewery, so whole day. Okay, this is very tiny work, but it's very important for the local industry. So finally, two more interesting future is a KDDI slogan for 5G. So finally, I will show a rather future-oriented world 5G will create. It is an experience of avatar. So you know that the tele-existence is a robotic system that can expand the presence of human beings. So we collaborate with the venture company of tele-existence. This is a human tester left. Who wears the gloves and goggles to control robot. And right side, this is the remote robot with the touch sensors and thermal sensors to feedback the tester by way of 5G with low latency. So the robot can be very far from the tester. So we can grasp every object with our robot hands. Okay. Yes. So this is the tele-existence in the hall. The tester wears the gloves and to control the field haptics. This is the gloves with many sensors. So he can feel the haptics as well as the temperature also. So he also wears the head-mount display to see the robot's view. So his movements are synchronized with the robot right now. So this is the preparation. So when he shakes hands with a lady through the robot, he feels the tactile feedback. And his view is on the screen upside, and he can grasp a ball very easily. The controller is a tester, so he can grasp the ball, and okay, I will skip. Okay. So he can grasp the plastic cup and maybe pouring the glass ball. Okay. So we use such kind of avatar robot and experience of the remote traveling from Tokyo to an Ogasawara Island, which is 1,500 miles away from Tokyo. So I hope it works. Okay. The final video today's. So the left Tokyo, the right Ogasawara. So left, the tester watches a robot's view like this. A guide person with the blue ocean. And he shakes hands with guide and feels feedback. And he saw robot itself view on this mirror, the left side, left upper side. So next experience is the touching a sea turtle. So the robot touches, so he feels the touching sense, hard or soft and harsh and smooth. So even the temperature, warmness also. So next action is that feeding cabbage to the turtle. Okay, he grabs the cabbage and turn the palm down and drop. Okay, you see the left side. He saw the turtle just in front of him. Okay. So he says goodbye to Ogasawara, to the people. Okay. Okay. That's one. Okay. How was that? So this is again that go to a more interesting future slogan to 5G is KDDI's slogan. Okay, so today new world explored by 5G is widely forecasted and introduced, but 5G is just in front of us. So KDDI will lead various initiatives, provide an unlimited world in the coming 5G era, but all of you will make it So thank you for your kind attention. Thank you.